Well, my name is Ilan. I'm going to talk about decentralized service, the RIF name service. Um, so let's get started. First, I'm trying to explain what the service is about, what problems are we trying to solve with this decentralized service. Then after I explain how does it work and what are we trying to solve, I'm going to show you how it is built, and then I'm going to explain some of the current plans we have for the future. So, well, first, first of all, I think that you all know how does a browser works. So, for example, when you were trying to reach the event, you found someone sent you in WhatsApp a link, and you read in that link that it's Zoom. So you know that when you are going to enter the site, you are going to see the Zoom website, and the pop-up will appear for you to connect to the call. So actually, behind all this technology, there's a service called the DNS. So the idea is the following. Let's say you are going to find Twitter webpage. So you write in your browser twitter.com, and that you remember Twitter, and you know also that when you write twitter.com, you're going to enter to the Twitter application and not Facebook application or Instagram application. And once you put that URL in your web browser, in behind the scenes, what is happening is that your browser is going to this service, the DNS service, and is trying to fetch something that is called the IP of the computer. The IP of the computer is the location of the computer. It's a way to identify all the computers uniquely. So if you have the IP of a computer, you know how to access information in that computer, the available information, of course. So this DNS service in behind the scenes finds this IP and then returns you once you want to fetch the site, you ask for this IP for the site, like for example the home page in Twitter, and this will send you back the home page. But behind the scenes of DNS, there is also another behind the scenes, that is how Twitter could put their IP in the service and trust that it will work, trust that it will be saved for the eternity, and also trust that nobody will try to hack it, nobody will try to change it. So something similar is what we are trying to build for blockchain technologies. Now in the blockchain technologies, you kind of, when you try to send money to another person, you have to put this kind of IP of the person in the wallet. So what you try to do when you send money is you ask the person for something that is called the address. The address of the person is the unique identifier, but for cryptocurrencies, not for websites like it was the IP. Then you copy and paste this long thing that you can find over here. You put the amount of money you are going to send to a person, and then you send it. But all these characters are quite strange. People does not remember them. They are difficult to be sent. Also, they are error prone. Like for example, if you are copying a person address with your hands, then you could easily fail on one character or two, and you're going to send the money to another person or even to nobody. So what we are trying to build is kind of this DNS service, but for the blockchain in a decentralized manner. So that when you want to find a person and send him money, you can do it easily. You can just put the domain of the person and send the money, and you don't have to think what is happening on behind, that you know that you are sending money to that person and not to another person. So I was talking a little bit of DNS, and DNS has an architecture that is quite distributed, is differently from decentralized. The idea of distributed is that the database where they store all these domains and these IPs is placed in different parts of the world, and it's distributed around the world. And the records that you can find inside there, they are also distributed in different databases. But that does not mean that it's decentralized, because when you try to access that database, you are going always through the same endpoint, and you are going to find the IPs of the computers doing always the same path to the same record. So that's kind of the difference between distributed and decentralized. What we are trying to build is a service that is fully decentralized, that you don't, in first place, you don't need permission to use nothing. Then in the second place, the decentralized stands for that you can actually copy the database and have the database stored in your computer or in your data centers or anywhere. So most of the motivation of this service is trying to reach the unbanked people in this RIF service, as there are a lot of the RIF services, and in RIF, the whole motivation of the project is to reach the unbanked people and give them services that are trustful and that are cheap, and also that are decentralized. So this is one of the key things to reach this kind of users, because usually the not banked people are also non-technical, so making them remember a lot of letters and numbers and explaining why do you have to remember that and all that kind of things, then that put the people far away of this technology. And just telling them, okay, you just remember your nickname, and once you have to get money, you use your nickname to get money. That's the easiest thing I ever listened. Like, if you want to send me an Instagram message, you just need to remember my username, right? Not an IP or nothing strange. Then all the service is built on a blockchain architecture. It's a smart contract architecture. We are building it over RSK blockchain. Sorry. So this architecture we inherit from this architecture all the decentralized attributes it has. You can join the network, the RSK network, when you want to, when you need to. You can sync your own node. That node, including different things, it will include also this database of the RIF name service. It will download you the whole registry. Once you need to operate with this service, you can do it with your own node that is connected in as you think it's okay to the service. So that is how we build something that is fully decentralized. Then in the service, we also develop following some pillars that we find, and we try to ensure and to give to all the users. And in the first place is the ease of use. So all the whole service is intended to make the blockchain easier. So the ease of use is one of the most important things when we are building new features, when we are building anything we have to build to make this product real. Then the interoperability is another key point of the service. So maybe you heard about the Ethereum name service or the domain name service, as I mentioned before. What we are trying to build is something that is interoperable between different services. So if you decide to use the RNS, you will be able to use the RNS. But if you decide to use, for example, the Ethereum name service, then you will be able to use the Ethereum name service and follow all the RNS protocols. You will find that they are interoperable between different blockchains. So you can store your records anywhere you want, in any service you want, and it will work. Then like the floor of everything is the security. All what we build should have no bugs, should have no problems, and security is, for me, it's a concept that is very interesting, because the people should trust the service should also trust the people. It's like a two-way compromise. So what we build is fully secure. So when, for example, you are doing an operation in RNS, you're trying to update your address or something, then you can ensure that it will be updated and everybody will find the result, and everybody will start using the service with the latest updates. Then last but not least, we have the rentability. So to reach the unbanked users, for sure the service should be should be rentable. You should be able to buy domains cheap, to use domains cheap, and then the domains will have value in order of time, right? So so using this service as a cheap service is one of the most important things. So now I talked about how do we build this and what do we try to build when we build this. So let's see how do we actually build this, and let's see what we done in the team, and also what we want to do in the team. So the service has 4 layers. We develop in the RNS team, and in the RIF labs, we develop the whole architecture, the 4 levels of this, and the idea of having the first now you're going to understand the importance of each of the levels. But what we have is like first a level that is like where we define the protocols, where we define the specifications on how to use the service, where we define just in words, we say, how do you use the service and how should you use the service to find the things you want to find inside. Then we have the smart contract layer that is a part of the blockchain. Then we have the libraries layer that is the one that connects with the blockchain and allows users to use it. And then we have a decentralized application. So the specifications, mainly what I want to mention in this brief talk is that one of the most important specifications is that it's quite similar to the DNS service. So we have a tree structure, and then in this tree structure, you are owner of all the sub nodes you have below you. So for example, if you are Alice over here, alice.rsk, then you will be able to create, for example, wallet.alice.rsk for free, or games.alice.rsk, or for example, imagine that inside our RNS we have all the Google records, so Google could be able to create calendar.google.com. And then the other very important thing of the protocols is how you find information here. So all the protocols also will define how you find a record in this tree. Then given that record, you can find all the information of this record, like for example, the address, or for example, in the future, the IP, or anything you need to find on the domain. Then all these protocols should be implemented, right? Like saying things in Word, it's not enough. We need to make a computer science project, and we have to build it, and we also have to make it work. And the smart contract are like the core of the whole product. The idea is quite similar as DNS also. If you ever listen, you are going to understand me these 3 words that are very common in DNS. Maybe if you don't understand me, pay a little bit of attention. We have the registry. A registry is a place where you save records. So we have a smart contract that is the RNS registry. It is permissionless. So once you acquire a domain, you can operate with the registry directly, and nobody can ban you, nobody can prohibit to use it, and nobody can enforce you to not update something. Then this registry, it stores 2 things. First, it stores what is the resolver of the domain, and also what is the owner of the domain. So these 2 things are very important. If you are the owner of the domain, you can create subdomains, you can create new leaves in the tree. And also what you can do in your domain is to have a registrar. A registrar is a contract that allows you to create new leaves in a decentralized manner. So, for example, in RNS, we enable the .rsk domains, and we have a registrar contract. So through that contract, you can acquire, for example, wallet.rsk, right? And in that contract, you will have all the things you have to reach to get your domain. Like, for example, you have to pay, I don't know, 2 RIF tokens for 1 year of the domain. Then you have to follow this process of 2 transactions, okay? So everything is defined in the registrar. Then the registrar, once it finishes the process, it ensures you that you are going to register a domain in the registry, right? So you are going to actually get your domain, and you can be sure because it's fully secure and it's fully decentralized. So then the other thing that domains have is a resolver. So that's the other component. In one side, I talked about how you create new domains and how you can you use your domain to create more domains. So now we build an enormous tree. Now we have to give functionality to these domains. And this is given by the resolver. The resolver is another contract that has the domain, and the resolver, the first thing is that the user can choose anyone he wants to, and the definition is quite similar to the DNS too, and the resolver provides of information to the one who wants to query for the domain, right? So if I send you my domain, ilan.rsk, then what you are going to do now we are going to see that it's quite easy to do all this, but first you are going to go to the registry. Then in this registry, you are going to get the resolver, and this resolver will tell you, okay, Ilan's address is this one, his website is over here, and you can find his, I don't know, payment channels over there. There are a lot of things you can store. So there, accessing the resolver, you are going to find all the information I am providing. And also the important thing, as I said before, is you can choose your own resolver. So if you have a particular use case, you can build your own. You can create your protocol. You can plug and play your domain to a new resolver, and then just let people use it in the same decentralized manner we are using ours. So that's why here I put some box that is the default resolver, that is the one that we provide. And also, well, there are a lot of resolvers that can be customizable, right? Now, all the things that I took are quite far away from a developer, right? So developers nowadays have know some languages, know other languages, know how to use open source, know how to use GitHub. They know a lot of things, but nothing about blockchain, right? Most of the developers just listened about blockchain, just tried some things in their computers, but the productive services are there are a few in blockchain space. So what we try to do in this step of the architecture, in this layer, is to enable all these protocols and smart contracts for common developers. We want people to just plug and play to our service, right? You want to, if you, for example, are Google Chrome and you want to integrate with the RNS service, maybe you want to just read the specifications, see they are okay, and plug and play the product, and not go to the smart contract architecture, analyze all the process, where should I make the queries, and then try to build all the service in my own development environment just to make some queries and start integrating. So with the RNS libraries, what you can do is just use the library and use it as a common library you would use it. Our main library is the JavaScript one that enables you to resolve any domain. So you can just import the library and query for a domain, and you will actually find the address of that domain in seconds and in just one line of code. And then this JavaScript library also enables you to do a lot of operations, like for example, operate with subdomains, change records, and all these things are done in a decentralized way, right? You just get your RSK node, you plug the library to your RSK node, and then the library resolves everything of the interaction with the node for you, but you can choose the node you want to. So if you want to use a public node because you think it's secure, then you use that. If you're, for example, you have a high security level to build your application, then you can just sync your RSK node and connect locally and do the connection you need to. Well, we have the Python, Go, C#, we have some other libraries, but all that libraries just are implementing the resolution protocols. So to operate with the whole service, I recommend to use the JavaScript library. Then just to make queries and all that, you can use all the other libraries. Once we have all this, we need to reach end users, right? So that's why we build an application. On top of all this, like we have the specification, how it works. Now it works because we have the smart contracts. Now it is easy for developers to integrate because we have the libraries. Now it should be easy for people to register and administrate the domains, right? So you should be able to go like a GoDaddy, register your domain, then administrate your domain, then just use it and send it to your friends. Like for example, I created my blog and I got my domain, ilanolkies.com. So that was like 5 minutes of, okay, I have my website here, then I have my domain here, I have to plug this domain to this website, and now I'm done, right? Just with that, I'm done. So that should be as easy for anybody, and anybody who wants to use the service should just search the domain, register it, follow I think it's 2 or 3 minutes, you have to follow some steps. It's make 2 transactions. Then when you have your domain, go to the admin part and set your address, and you are done, right? That's the happy user, and how we reach different kind of users, because once they have this, they can just use it in other applications, and we can build this big environment we want to build. So just going to the end, I have just 5 minutes. I'm going to talk 2 minutes about why would you choose RNS, and then leave 2 minutes for questions. First, we have some features. I'm going through all the features fast, and then I'm going to explain the future plans. In first place, as I mentioned before, you can create 2 domains. So once you get a domain, you can create actually all the subdomains you want to, as the same as DNS. Also, this domain, you can use it for different cryptocurrencies. For example, you can get your domain and then set it up to be used in the Bitcoin blockchain, for example, and then in the Litecoin blockchain, and then in the Ethereum blockchain. You can use your domain in different applications, in different blockchains, and the whole service is still stored in the RSK blockchain. So what the applications would do is just go and query the RIF name service to find, for example, the Bitcoin address, and then use it to send the Bitcoin assets, right? Then you can also plug your domain to your website. We integrated with, we have a slight integration with IPFS and Swarm. So these are common distributed services for storing files. So what you can do is get your domain, right? You register it, all that, and then once you want to administrate it, you plug it to your IPFS or Swarm hash. That's, if you know about IPFS or Swarm, it's very common to listen about the IPFS or Swarm hash. It's a common word. It's the identifier of your file. So you plug it to your file, and then once the people want to access your website, then they will go to this IPFS service in behind the scenes and get your files and show them in the web explorer. Then we also enabled reverse resolutions. So you can, now what you can do is, as I mentioned recently, is to find an address of a domain. You can do the other way around if the user enabled it. So if you find that you receive money from an address, then you can analyze who the owner of this address is and try to understand who is sending you the money. And then also I speak about the customizable resolvers. You can unplug the default resolver and plug your own resolver that fits best for your use case. And it's quite easy to do that. It's cheap, and then you can provide all your application users with the records you need to use your application. That's great. And some little plans we have. In the first place, we want to enable a lot of new features with the records. So what we are working right now is to add a lot more of records. For example, adding TXT records, adding public keys to the service, adding a lot more of information that the user should be able to provide by default, right? So as I mentioned before, you can just create your custom implementation, but what we are doing is create a standard implementation for all these kind of records. Then also what we are trying to build right now is that you can use our libraries to use RNS domains or also ENS domains. ENS is the Ethereum name service and RNS is the RIF name service. So what this library will do is like, okay, I found the domain in the RNS. If I don't find it, then I'm going to try to find it in the ENS service. And if I find it, I will use that domain as the main domain, right? And the other nice plan we have is that the domain name system, the DNS, has a lot of registered records that are not decentralized. So we want to enable a way to people that already own a domain in DNS can claim it inside the RNS and use it in a decentralized manner. So well, I will send all these links. This is me. You can find a lot more about the service in all these links I will send, and also you can find more about me in these other links I will send. So I'm open to questions. I'm going to move to the chat. Thanks everybody for listening. It was quite fast.